Okay, simplifying this complex fraction, I'm going to work exclusively with our numerator, then come back and work exclusively with the denominator. I need a common denominator, and so I'm considering to myself, what does this denominator have that this one needs? Well, this has an x plus 2. This does not have an x plus 2, so I need to give it an x plus 2, if you will. And so I'll multiply by x plus 2 times x plus 2. X plus 2 over x plus 2. And I'll consider, okay, well, what does this denominator now have that this one needs? This has an x plus 2, x minus 1. This just has an x plus 2. So I'll multiply by x minus 1 over x minus 1. Now I'm going to rewrite here. Okay. So you can either rewrite, or you can go ahead and expand this x plus 2, x plus 1. So let's go ahead and do that. I'm going to multiply, and I know I'll have x squared plus 1x plus 2x plus 2. And so when I combine my like terms there, I'll have x squared plus 3x plus 2 all over that common denominator, x plus 2, x minus 1, take away. Now I'll come back over here, and I'll put this in parentheses, and I'll expand that. X squared, take away x, take away another x, plus 1. So that's going to be x squared minus 2x plus 1 all over the common denominator of x plus 2, x minus 1. And I'm just going to expand that fraction bar there. Now it's going to be important to put parentheses here. Why do you think that is? It has to do with our minus here. We're going to have to distribute a minus to each of those three terms when we combine this fraction with that fraction there. And so I'm going to write this out as x squared plus 3x plus 2, take away x squared minus 2x plus 1 all over the common denominator x plus 2, x minus 1. Some people will skip this step and they'll go straight to distributing this minus. I like to write out all my steps here. So now we'll distribute. The x squared plus 3x plus 2 remains unchanged. We'll have minus x squared, negative times a negative 2x is a positive 2x. Negative times a positive 1 is a minus 1 all over our x plus 2, x take away 1. Okay, so we have the x squared, take away x squared, that's going to sum to 0. Let me change colors here. X squared, take away x squared, sums to 0. We're going to have a 3x plus a 2x. I know that will be 5x. And then we are going to have a positive 2, take away a 1, and so that will be plus 1. I think my fraction bar over here is a little big. Let me get rid of a little bit of that. And that's still over our common denominator, which was x plus 2, x minus 1. All right. So that's the numerator. Now I come back to here, 15x plus 3 over x squared minus 1. There's no fractions to combine here, which is nice for us, but there is some factoring that we can do. I notice that there's a common factor of 3 in 15x plus 3, so I'm going to factor a 3 from that expression. And we're going to be left with 5x plus 1. And then I'm looking at the x squared take away 1. And I know that is a special binomial. That's a difference of squares. So x plus 1, x minus 1. And there's nothing left to do. So I would write that here. And I would write it here. But I'm going to go ahead and transfer that down to 3, 5x plus 1, all over x plus 1, x minus 1. And now I'm ready to multiply by my reciprocal. All over 3 times 5x plus 1. So x plus 1, x minus 1, all over 3 times 5x plus 1. So 3 and 3 reduce, 5x plus 1, 5x plus 1 reduce, x plus 1, x plus 1, x minus 1, x minus 1. That should happen every time when you multiply by the reciprocal. In the numerator, I see an x minus 1 and an x minus 1 on the top and bottom. Those will reduce. I see a 5x plus 1 and a 5x plus 1 on the top and bottom. Those will reduce. And I think that's all that will reduce. All I'm left with now, I see x plus 1 on the top. And in a denominator, a 3 and an x plus 2. And I'm going to leave that in factored form. And we're done.